No, it's not this. So if this is a type 2 query, I'm changing something, it affects everything after that. If it's a type 1 query, then I aggregate it up because it's being changed by the things before it. So you aggregate the type 1 queries from the right and the type 2 queries from the left, I think you don't even, I think you just pass those up. No, you need to pass up both of them though. Because here you would say, well, this is going to be affected by this. So pass up the type 1 query, but then if this was a type 2 query, you still pass this up because you never know when it'll become used. So you pass up both queries. And you'd say, I have an answer. I have a binary indexed tree that's default for everything. That's the initial state. So I don't actually want to include this. Right, that's insert everything into the binary index tree. If this is a Y, you just query the binary index tree. No, that's not right. Well, here what you would be asking if you're at some random Q1 at T at I, you're really querying 4 things: x0, x1, y0, y1. If you sweep line through x, you take a prefix sum. That's understandable. If you maintained B, we got that, and then A, is a binary index tree. So if you maintain B, then for any type 2 query, you just swap it. That's fine. Right? And then for this, you just need... No. Because you need to add stuff in here. You need to modify a binary index tree. You can't shortcut that. Or can you? I don't think so. You're saying parse all of the type 2 queries. Once you've done that, let's see, you're modifying these queries, you're building them up. So the moment you get to something as a rightmost query, is that true? Yeah, the moment you reach something as a rightmost query, if you DFS, you know that every no. If you're going post order, you don't necessarily, if you're querying here, you have this info. You don't even have this info, you just have this. You parse here, then you parse this and then modify this query with that. At the point where you merge this, you need to be able to take 2 queries and that's it. Right back. Test 1, 2, 3. Yeah, that's good. So you really have 4 queries that you care about. And they can kind of be condensed to 2 range queries. You're saying, what's the range query from y0 to y1 at x0 minus 1? And what's the range query from y0 to y1 at x1? And then you subtract them. And then you get this rectangle that you care about. And at x0 or x1, you're saying, what are all of the elements included in A for up to this index of B? So if you inserted all of the values of x, that's not really useful. Okay, you do one global sweep. No, this is for... Can't do one global sweep. Instead of a single physical sweep of X, you simulate the accumulation within each CDQ merge, restricted to the updates before the query. Each CDQ merge handles a local time interval, not the whole timeline. So those left updates can safely influence those right queries. So are you purely measuring I think you're purely measuring the effect that the updates have on the queries. Okay. So you'd say, I have no idea what the answer to this is, but I know that if this was query 2 and this is query 1, that this is either going to add or remove or have no effect on this query's X range. So you line up all the X's. Is that right? You would add or remove them. No, because you don't know. No, maybe. You would need to do it in the right order. Because if you swapped this element with this element, and then this element with this element, that's going to get you a different answer than if you had done this swap and then this swap. So You need to make sure to order them correctly. I think that makes more sense. So you're purely measuring not the actual answer to Q1 when you come across it, but purely the effect that the previous queries had on Q1. And then it just becomes a matter of, if you have all these Q2s, doing them in the right order. Which would mean, does that make any sense? I don't actually think that's right. Yeah, I don't know about that. To compute the influence efficiently, perform a sweep over X only over those two sets left updates right queries. Yeah, but what does that mean? So you'd say, this X got swapped with something else. This X got swapped with something else. Maybe you can do it backwards. No. Because if this query 2 right here, if this moves some index in, you don't know what was at that, because some previous query 2 could have changed it. Unless you can compose it backwards and you say, I don't know what was at that, but now I do know what was at that. Because you're going backwards, you're just saying, now this would have been swapped with that. That's not right. That doesn't sound right. The CDQ recursion reaches the merge that separates its preceding updates from itself. The merge's local sweep over X inserts exactly the relevant updates. Performs one bit query over that X to Y. just don't really know what it means. Like, how do you sweep over X? I think it is you're not actually answering query 1 here. You're just answering how it's affected by previous query 2s in its like CDQ node merge step. But it's not clear to me how you would do that backwards. Perfect, blah, blah, blah. Add a CDQ node. Left side, okay. It keeps saying that. That's great. All updates. So X is position A at V, Y is position B at V, and delta. What the fuck is this talking about? Add the coefficient times f of x and y. I'm imagining it's just like spitting out garbage because this is like a rare enough problem. There's probably some other thing that uses a coefficient. We need to count all the left updates where x is less than or equal to x and y is less than or equal to y. So all the updates that will not affect. Oh, okay, well you sort them. That's kind of important. And then use 2 pointers. So for every query in write, you're querying everything below some x, below some y. Oh, I see, and the coefficient is just like 1 or -1 or something. Okay. Roll back bit.adds afterwards. And left at p.x is less than or equal to query.x. Okay, that kind of makes sense. I'm still not understanding. I don't think you can compose this like this. It's exactly why CDQ is doing divide and conquer on the time dimension rather than just recomputing positions in some arbitrary order, okay? In my mind, it's doing it exactly backwards. So clearly they found a way to make the swaps be in order. So for every query on the right, you're doing a 2-pointer where you're saying look at every left at p.x they're saying like if you have some point, I don't know why they said at P, but as long as you're updating an X value that's below the query's X value, then it's relevant. I understand that. And then you're adding in that thing and then you're going up. But in my mind, you're going in a pretty random order with these updates, which like you can't do. Left side represents the state of the world so far. Right side get their own answers as if all those left side updates had already occurred and none of the later states had. Take a single swap of elements I and j in permutation B. Each value has a fixed x. Even though within a merge we sort by X spatially to process left updates efficiently, okay, the recursion ensures those left updates only represent operations that truly happened earlier in time. Within a single half, the relative order in time doesn't matter anymore because each update is just a delta to a single point's Y count. They commute with respect to counting queries. That doesn't sound right to me. Okay, they don't commute globally. You want the different rotation than doing them in the opposite order. Oh no, he's using LLMs, I know. It's tough because it's really hard, like right here, I'm like, wow, it's really hard to tell, is this thing just wrong or am I not understanding it? And I think I happen to be the right combination of like open-minded and able to think really insularly that I can kind of like weather that, but it's tough, especially when it turns out it was just wrong and I'm like, oh, I don't know what the fuck I was talking about. CDQ never tries to reconstruct the current permutation for B. It works purely with deltas over time, answering each query as if it saw the entire timeline and adds removed applied correctly in sequence. So I think it is just working backwards. I think it's phrasing it wrong. I think ChatGPT is always going to tell you you're right. That's why I tend to be pretty careful with like right here, I'm like, wouldn't this not commute? And if it's able to tell me, yes, it won't commute, then I don't know, that means something, but it's not even saying that. It's saying it doesn't commute globally, but it does locally. So it's not quite agreeing with me, even though it's kind of sucking my dick here. It's like, excellent, you're 100% correct. Absolutely, that's exactly why, blah, blah, blah. Now you're getting to the heart of it. I'm like, whatever. Okay, I think what's going on though is it is commuting backwards. And it's different when it's commuting backwards versus forwards, but that doesn't mean it's irreconcilable. Like there's still a rhyme and reason to it. So if you say, okay, yeah, I'm kind of persuaded. So if you have three, let's say this is the range you're going to query, and what you need to do is you need to make two swaps. This swaps to here, and then this same point, because otherwise it's irrelevant, swaps to here. So what you're going to have in the end is this point is here, this point is here, this point is here. That's what it's going to look like. The problem is with the divide and conquer, let's say like this is this, and then you have another Q2 query here, and this is this. The problem is that because you're doing like a recursive divide and conquer, if this is this query, then you'd say, okay, well, first account for this swap and then account for this swap. But you can't do it out of order. That's going to give you something different, right? You're going to say, well, then this is here, and this is here, and this is here. No, yeah, I'm still not convinced. But I think you can still do it. You just need to be slightly smarter about saying, well, no, I'm like the first swap, quote unquote, the first swap that I parsed, which is later in time, I'm saying, I know for a fact that this is here right now and it's moving to somewhere else, to there. And then there's something here that's moving to here. And then what is this? Well, now I know that this is, whatever this is included. And right now, what this is, as far as I can tell, this. But then I learn in the second swap, actually, it... Let me think about this. That swaps to there. No, you don't know either of these. There could have been another swap that was like that. And then at this point, like, you have no idea what this is and you have no idea what this is. You're just swapping random values at random places. But I still think you can parse it backwards. I think I'm overcomplicating it, and when I come to like whatever algorithm it is to do this, it's going to look like dead simple, and there's going to be a much easier way to think about it, but so you're saying, how do these swaps... Is it that you're... no. Is it that you're only looking at swaps? Because ultimately, like, yeah, when I look at query one, I'm saying, what's everything in this threshold? But really what that's going to come down to is actually two queries where I'm saying, what's everything before this? Subtract that from everything before this. So really I should just be looking at like what's everything before this point, and then maybe that kind of opens up a door like conceptually where you could just say, well, I don't really care about what the points are, I just care about whether or not they're before or after this. So then I'm just like, does it swap to before or after? And then I change the binary index tree accordingly. I guess. Let me look at the pseudocode again. Because I have more confidence that the pseudocode is like, where is it? Doing something kind of correct. Because this must be yanked from like something someone else did. You sort, you two pointers, you say for every query, look at all of the X values that are being swapped prior to this query. You should try this contest. I can take a look at that. I really want to, okay. No. Left to p dot y, left to p dot delta. Oops. Yeah, I think I might have been right when I was saying, so you have these points. Let's say your two queries are like this swaps with this and this swaps with this. I think what this is kind of saying is like, well, you don't actually give a shit about removing this in a way. You only really care about the fact that now this has come before the threshold that you care about. Or it could have been removed from the threshold you care about. Because what I'm noticing is right and left, query.coefficient, for every query in right, it's just it's like a little confusingly written, because I'm like, okay, so they're saying you have a right. I don't know about this. It's saying you're reconciling right with left, but there's no distinction whatsoever between, I guess, what's a query and what's a swap, unless they just assume, unless this like weird code snippet means right and left are actually like different. Like this is the, how do I put it? This container is actually containing like kind of essentially different information than this container. They're not both containing swaps or both containing queries. This is containing queries and this is containing swaps. Whatever. I'll go with that, because I guess that seems like really terrible form to write it that way and name it left and right like that, but whatever. X for updates, capital X for query terms. So the queries are just basically two values. It's what is before some X and before some Y. That's basically what it's coming down to, is I have a big rectangle of values. You could just use like a 2D segment tree, but the problem is that's O of n squared log n squared. So you can't do that. So instead, we're trying to kind of simulate like, okay, there's some X and Y here. What's the sum of all values in here? And then I'm changing them over time. So here, let's go back to this code. So I'm saying sort the queries by the X value. For every Y value, my washer is going to keep beeping at me. Be right back. So just dot delta here just kind of means like, are you adding it in or taking it out? And that part's not really phasing me. And then query.coefficient is the same thing, because if you're, what we're really trying to do is say you have some rectangle. Let's say this is your rectangle you care about. So how do you get this without having to count every single individual element? Where you say, okay, what's the sum of everything here minus the sum of everything here minus the sum of everything here plus the sum of everything here. And then that gets you this amount. So you're splitting it into 4 queries. And then all of those queries decompose to what's the sum of everything below a certain x and below a certain y. But then some of them you're taking out and some of them you're adding in. So that's what this coefficient is. That's fine. And then bit.sum query.y, that's saying like at a given x layer, you have some sum of values up to a given y. So like right here, maybe you have these or something. And then that would be like 4. So ideally what bit represents at the end of all of these is just literally the answer to this. It's at some x value that you've parsed, the total number of elements under a given y value. The state of the BIT, the binary index tree, is what x you're at. So you go and you go and you go, and then at any given point you can say query the binary index tree for like exactly that or exactly that. You could decompose this into 2 queries instead of like the 4 like this to get this area. You could just say, well, I mean, like it's a slight modification of the binary index tree. It's semantics to just be like, don't get the sum up to something, just get like this sum minus this sum would give you this area. That would be fine too. Or like the sum of everything in that area. But it doesn't really matter. So you're changing query.id a lot. You're changing it like log n times per query. Because you're saying at some point, here's all the values inside of this range. And then at some other layer, when you're at like this merge layer, oops, or if we're looking at this merge layer the whole time, if you're at this merge layer, you're going to change it again. And that's actually kind of important because like one of these swaps, let's say this one is this query. I'm just going to call this like, I don't know, Z2. And this is Z1. So this is Z2. And then let's say this is Z1. I just still don't see how, if you parse this backwards, you're saying whatever this number is, 5, and this is 1, 5 goes here. The one and only. And then whatever number this is, let's say 3, 3 goes here. So then in the end, you'd have like 1, 5, 3. But that would be wrong if Z1 occurs first. Oops. This seems really rudimentary, actually. This seems like I should definitely be able to just figure this out more quickly than I am. Because just like how you could say, well, if there's a 1 here, and let's just say a 2 and a 3 here, if this swap happens first, and then this swap, then you'd go from 3, 1, 2 to 2, 1, 3, and then that would become 2, 3, 1. And that's different than if you parse this first, but I think you could say, I'm not saying this happens first, I'm saying this happens the most recently. So then you would say, okay, so it goes from 3, 1, 2 is what I think it is initially to my best guess is 3, 2, 1. If I parse this first, and if this is the only query, that's true. But then I would look at Z1 and I would say, it's not 3, 2, 1. It's 2, 3, 1. Because this is now swapping with this. But I don't see that accounted for anywhere in this logic. Left at p dot y, left at p dot delta. I'm really not understanding that. And its answer is so lackluster. I'm saying, doesn't the order of swaps matter? You can't just compose these however. And it's saying, yes, that's why we do it in this way. Which makes sense, because you can order it. You just have to order it backwards. But I'm like, how does that help us at all? Maybe I'll just ask it, I don't know. Why the order inside the left half doesn't matter. You take two swaps S1 and S2. Their timestamps are earlier than any query here. That's fine. So by the time we answer those queries, both swaps have occurred already. Okay, I understand that part. It doesn't matter in which order they were applied. The only thing that matters is their combined end state that has been reached. That does not sound right. CDQ is not combining arbitrary prefixes. It always merges contiguous time intervals. And within one interval, we never partially apply a swap. Both updates from it are in the same side. So we swap ij, we swap jk, and then we query. In the recursion, 1, 2 equals left half, 3, 3 equals right. It's just saying, okay, like the query is in the right half, so we do both of these first. My thought process is that it really matters what order you do this. We feed in the final x, y positions of all our elements after both swaps 1 and 2. The BIT doesn't care about how we got there, only that these are the points that exist at time equals mid. If there were another query at t equals 1.5, the query would instead be in the right half of the earlier merge, where only the first swap's updates are visible. Okay. So its result uses the state after swap 1 but before swap 2. So I think the part that I'm missing, the reason why it is commutative, I think, is that you're not just doing this in isolation. The binary index tree was already changed prior. So you're actually like layering on these swaps simultaneously. So if Z2 happened, or if Z1 happened first, you would have already swapped 3 and 2. I'm not really fully convinced, but so what happens here? You have, let's just make it for the sake of simplicity, 1, 2, and 3. And this is where your query is eventually going to be. So query, I'll say Z1 is going to be swap 1 and 2. Z2 is going to be swap 2 and 3. And then Z3 is going to be query less than 3. Query less than index 3, or just like query everything before this line. And then that's fine. We can like, we'll know how to do that there. That's totally fine. So according to this, what would happen is that the order completely doesn't matter for these two. So you just swap it however. However, no, I think it has to play out. I'm really curious. Because what's going to happen is if you swap 1 and 2 first, then your binary index tree represents like the locations of all the values. You're using, this is the structure in which you're swapping everything, so that's fine. So you would say swap 1 and 2, and then that was the first thing you had done previously when you were here. And now you're at time step 3, so you're here, and then you swap 1 and 2, and you swap 2 and 3. Still seems wrong, right? That seems like not the right answer. Like, this is actually an example of how that doesn't work. Favoritism. I know, Solaris, I never see your streams anymore. This feels like a trust the process kind of thing. I'm still not under. I'm going to give it one more shot. Why the order doesn't matter. This just still seems wrong. That's how CDQ. Hey, simple colon. Was there a contest today? I feel like this was like really slow earlier, right? This is another problem I've been thinking about, and this one's a doozy, a div1h. I guess it's from way back, maybe. I don't know how long ago this was. And I'll never know, because it'll load this whole stream. Okay, I'm still not understanding. The order of swaps always matters. There's a chance it'll be like, oh, sorry, I was wrong. I just don't really know where else. I guess I can look at the tutorial for this. Test period about implementation, blah, 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 blah. Okay, you can choose the structure you want. I'll tell about the one I use when the queries are offline. For online, the common technique is to have n binary index trees, each with a treep in it. Ordered set template from PBDS is usually enough. So I think, though, this is fundamentally doing the same thing. It's fundamentally saying you only care about distinct X queries, and there's some way to not have to sweep line X for every single query or for all queries. So this would be like the next thing to branch to after this, but it's already like what? A div1e, so I'm not going to try that hard to understand the next thing after this. Very fair pushback. Completely correct for the actual permutation. Man, it really has to walk me through the baby steps here. For offline, you can pre-calculate the values to fall into each binary index tree beforehand and do the binary index tree on these values inside. Pre-process all the update and get queries, adding Y into all binary index trees X will fall into. Then sort them and leave only unique occurrences. I don't know that. I don't understand that at all. That's so vague. That could be saying anything. I did G just like immediately in like half an hour. That felt kind of good. Wait, did I do G? I think I did G. Maybe I did something else. No, I didn't do G. Wait, what did I do? Oh no, this was some other G. Never mind. Well, maybe I'll look at G. Because I think I just completely understand what to do with G. I think it's a lot easier than this. Okay, well, this is not really saying anything useful. Let's make the distinction absolutely explicit because this is the most common place people get tripped up. I don't care about that. CDQ does not simulate the real array B as swaps happen. It does not ever try to know what the permutation is. Instead, it answers all queries offline. You already know the full list of operations in advance. You can compute for every element V exactly when and where it is before and after each swap. Because the entire history is known, you can flatten each element's movement into a set of time-stamped point updates. At time t1, remove some value and add some value. Okay. Those updates have an intrinsic chronological order. Okay. We never try to re-execute swaps inside the left half in a new order. During the merge, we only ever let left half updates affect right half queries. That's all. Okay, that actually seems important. I think that does speak to the thing I was kind of thinking about. I think here, I guess I didn't implement it properly, but I'm surprised ChatGPT knows about such an obscure algorithm. I find only ChatGPT knows about these obscure algorithms. Like, on this dude's blog, where was it? He had a post in here about it. Maybe, maybe not. No. I don't know, maybe. What's it called? CDQ? No, I guess not. I don't know. Maybe if I go back enough, it'll show up. No, it won't. So you only care about you're saying I only want to know the way that that update contributes to this query, not the way it contributes to any other previous update. They are already represented as fixed atomic add remove events with timestamps. Within that left half, the internal chronology no longer matters for the right queries because every one of those swaps has already happened before any of those queries. So what the merge sees is simply, at this point in time, there are the cumulative add removes that have occurred. It is not commuting swaps. It's treating all events as time is less than or equal mid as done. So if we take these swaps, in my mind, it just absolutely matters the order, but it's about to tell me that I'm wrong. Doing them in reverse order would change the permutation, but it doesn't do them in reverse. The recursion naturally splits. The first recursive level handles the 1 to 2 swaps, and then the query. The merge from that node only includes the updates whose time is less than 3. That's exactly the state after t equals 2, the true state before the query. It's answering a question that I'm not asking. Like, I don't really care. I understand that like these all come before this. That's fine. But like, it's their order relative to each other I care about. If there was also a query after T1, but before T2, it would appear in different merge. One where only the first swap's updates are visible. That's also fine. I don't care about that. So each query is answered with exactly the set of swaps that chronologically preceded, no more, no less. Needs chronological execution. Set of XY changes caused by swaps. Order within one merge. All those updates are simply already done. Global order. So I understand what it's saying. It's saying at time equals 2, you would have done this swap. And then at time equals 3, you would have done both of these. And therefore there is a natural gradation to the way that you're doing the swaps. But I'm like, at time equals 3, you're doing this again. You're doing this swap again. Okay, one more question, because it does seem to kind of, well, maybe I'll reread this a little bit. Blah, 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 blah. We never try to re-execute swaps inside the left half in a new order. They are already represented as a fixed atomic. Okay. If we're not simulating or re-executing swaps in the left half, what does it even mean to parse the swaps in L before the queries in R? I feel like I can tell whoever poured this coffee has a cat. Okay. When you pre-process all operations offline, you translate each swap into 2-point updates in the 2D grid, where you're saying at this time, X old Y delta is -1. I see. Okay. Okay, I think I'm kind of a dum-dum. I think now I knew this moment was coming. I think I understand. I think I understand now. It's literally the contents of this, where ChatGPT is kind of saying, like, you already know what element's going to be at what spot in B at any given point. That's fine. Like, because like type 1 queries, you're not changing anything. Only type 2 queries are you changing. So it's saying, I can't believe I'm like thinking about it this hard when it's this simple. It's saying, you just already know what this is going to be. You already know what value is going to be here. You're going to have some like Q2 0, Q2 1, Q2 2, all the way to Q2 M. This is going to be all your queries. So when you reach this, you just already know like what's going to be the value that you're increasing or decreasing at some index. And then if you record it by the value and not the index, then you can sort it however you want, because then you're just like, well, whatever value is in whatever spot. Okay. So to come back to this for a moment, I'm still a little like, the fact that you're parsing the binary index tree multiple times, aren't you kind of undoing? So if we have swap 1 and 2, swap 2 and 3, these are kind of, their index is the same as their value, so it's not a great example. Maybe I'll say like swap, this is value X, this is value Y, and this is value Z. And these are now just going to be queries. I don't know. And this is a type 1 query. These are type 2 queries. So this is saying swap X and Y. This is saying swap Y and Z. And then this is saying query everything less than index 3. So when you reach this, you just immediately know it's saying X at 0 goes down. X is no longer at 0. Y is no longer at where Y is. Y is now here. and X is now here. And then same for Y and Z. So you'd say Y is not here. Okay, no, I understand it. I gotta eat. But I want to code this out first, and then maybe look at that contest. Okay, I understand it. So going back to the tree, I finally understand it. So forget all this. You're DFSing through the tree. You're saying apply all the updates, go to here. There's no updates. So whatever this is, you do it. And then you go up, you undo the update, whatever updates were there. And then you say, I'm at this spot. So merge all these updates, merge all these updates. And then you go up, or you go down to here, and then you go up and you say, okay, undo whatever this is. Now, whatever updates were here, put those in, and then go down. You merge those. And you're saying for any query on this side, for any query one over here, let's get rid of these. You've already accounted for these updates. Hello, fragile human being. I don't know what that means. So all these queries are accounted for. So if you're, let's say you're here. There's like a query that you care about, and there's an update here and an update here. So when you recurse into this area in the tree, you already have a, I'm just going to call this update 1 and update 2. I don't care. And then this is query. So when you're here, this update 1 is still there, right? And then you go here and you say this is an update. You don't really have to do anything. And then when you're at this query, this update's already been applied. You want to apply this update to the query. Yep, okay. Oops. And then you'd say, well, hold on. Because for this query, let's say like both of these updates mattered. Like, okay, update 2 mattered, that's fine. But then when you're looking at this query, you would say, like, look at the spot in the binary index tree that I care about. And then this is going to affect my query. But that could have been affected by update 1. But then when you're at this merge here, you're looking at this query again, and then it's affected by this update again, right? So how does that work? Sleep comes offline. That little piece of pseudocode actually was pretty helpful to look at. You roll back the vit.adds afterwards. But you roll back when you go up, right? Not when you go down. Or do you roll back when you recurse down as well? Because if you roll back when you recurse down as well, it kind of makes sense. So you merge left, you merge right. Or you CDQ, you do the same thing left, you do the same thing right, you merge left and right. You want the BIT to reflect exactly the left side state while merging, but once you go back up, that BIT state shouldn't leak into other branches, like the merge for the sibling r+1 and on. If you rolled back before recursing right, you'd undo the left state before it was ever used on those right queries. So here, I'll have underlined, meaning it's happening. So you'd say, okay, do this. Go back up, go down, don't roll back yet, do this. Go back up. Now you're modifying this query. But then you'd go back up and you'd say, okay, roll back this, but then do this again. That's the final piece. It almost makes sense. Okay, well, let's think about this. I'm gonna run to the bathroom again and grab some water. Okay. Oh. No double counting. When you recurse right, there are no left updates applied. Rights recursion only accounts. Oh, yeah, of course. Okay, duh. It's that update 1 is actually not still in effect when you're looking here, because when you recursed back up here, update 1 was removed. Okay. So I think the big trick here for me is that you've pre-calculated exactly what this update is in a way that makes it, what's the word? Composable? Is it the right word? I don't think so. Commutative, that makes it commutative with any other update at any point. And what that is just a value change at an index. Okay, I think I'm ready to code this out. Multi-dimensional queries, I'll get to that later. Did I already make this? Intersection of permutations. No. So I need a couple things. I need a binary index tree or a segment tree. And I need like a divide and conquer recursive formula, recursive function, which is fine. So this is going to be int n. I think that's all I really care about. Right? Yeah. And then I need A, B, the tree, and a few arrays to represent the swaps and what the swap values are. But I'll think about that later. So I'll start with the tree. This is the presence of a value at a certain index. Yeah. How big can it be? 2e5. We got the array in A, B. What else do we need? That's fine for now. We got N, M, the array. We got A, B, and then M lines that are the queries. For I from 0 to N. Oops. Okay. If we got a type 1 query, do something or else do something else. That looks pretty good. I actually want for query, I think I'm going to call this T for like time, because that's definitely going to be important. No, I'm going to call it query because I'm probably going to use T quite a bit. Well, am I? No. But whatever. No, yeah, I'm not, because I'm gonna parse it recursively down here. I have A, B. I also want the time domain itself. So I think I'm gonna say that's, I could call it events. I think I'm gonna do that. And it could be 2e5 by 1, 2, 3, 4, 5. This has 5 elements, so it needs to be 2e5 by 5. And it's going to be the type and then LR or X and Y. Event at t at 0 equals type. Or can I just say event at t is equal to type L1, R1, L2, R2. I think I can do that. Please let it work. Damn. Well, whatever. Type. That looks good, or else X, Y, event at 0 equals type. Event at, oh wait, why did these all say 1? Okay, that should be fine for now. B is that. I'll just quickly build the segment tree out. This M is N. No, I guess, wait, how do I do that? Oh no, it's that this needs to be M. Right? Am I crazy? Okay, fine. While n is less than or equal to, while n is less than m, n goes up. Okay, this needs to actually be a little bit bigger. What's 2 to the 19? This is what it needs to be. No, not this array, this array. Fill n, no, I want to copy. Do I want to copy? What the hell is this array representing? This array is representing a bunch of 1s and 0s. Oh my god. What's the initial state of the array? Oh my god. Did I just sacrifice all that time for nothing? Let's see. So the query just represents not in the bathroom anymore. That can go away. The query represents the way that these updates have affected anything. So you'd start out and it would just be empty, I believe. Looks good. Not talking to him right now. I think that's all I have to do for this. I don't really have to fill out any actual elements. It doesn't matter. Query. This is going to be all the elements between L and R. So let's see, do I have to propagate? No. So I can just say while L is less than or equal to R. I think it's while L is less than R. If R and 1, R minus minus, yeah, res plus equals array at R. If L and 1, res plus equals array at L, L plus plus. Right. Did I set up the segment tree yet? No. Where's the segment tree code? I haven't written one in a while. Damn, not a lot of segment trees. What the fuck? Blah, 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 blah. Modify. Update query. What the hell? Okay. Here we go. L and 1. Yeah, this is what I want to see. Have we solved the problem? No. I mean, I've started implementing it. I'm like, I have the solution in my head and it makes sense, but I just need to I forgot how to make a segment tree. Wow. That's extremely concise code for a segment tree. What the fuck? What have I been doing? and m is m, ai.clear. I don't need to do any of that. Well, I do need to say fill n array plus n. No. Fill it with zeros. Pair int x update. Well, I don't know what this code was doing, but that's not really what I want. What the hell was that code doing? That was weird. Res 0, return res. I plus equals n, array at I plus equals x. While I is greater than 0. Array at I is equal to array at I times 2 plus array at I times 2 plus 1. There we go. So I want to load up all the queries at the right spot. So three people got that. Damn, that's crazy. I think I want to say have all the time be one indexed. That way at time 0, I can just say update every single array. It's so confusingly written. Or it's just not confusingly written, it's confusing to write. let's see, at x equals blank, and then you have all the x queries, you're going to load up times 0 to be everything. So I think I really want this to be from 1 to m plus 1. And then that's the event that's currently there. At that time, so for every left and right, you're going to have all the current queries on the left side, all the current updates on the left, queries on the right. I don't want to do this. I think what I want to do is make all of the updates be at time 0, all the initial updates, right? And then how do I do that? I don't really want events to be in that sequence. I guess I want events to be like a vector of an array of vectors of events. X, Y, X minus, minus, Y minus, minus. I think I'm going to make a recursive function. The recursive function is going to be given a left index and a right index. Left and right indices. Oh, and it's going to return left and right, or no, type 1 and type 2 queries. And then how do I get all the initial type 2 queries in? I could just say if the index equals 0 or something like that. I think I don't even need to do that. I think I can say auto CDQ is equal to initial value of reference to non-const must be an L value. Oh. Variable discard with an honest shit. No return statement in function returning non-void. Oh. Maybe I just have a queries. Resi. Fill res with 0. Okay. Now I'm ready to make this. So it's got L and R. It returns. No, it doesn't even really return anything. If R equals L plus 1, excuse me, CDQ 0 M CDQ. So let's see, left updates is going to be a vector of all the swap operations, and the swap operations are going to be what index is going, has what number that's going up or down. So index value delta. The index is going up or down by a certain delta. And then the query is going to be what Codeforces question is this? Intersection of permutations. There we go. Okay, what's the actual query? L1, R1, L2, R2. Auto CDQ. Okay, it's doing a bunch of random stuff. What's the actual problem here? CDQ undefined. Expected a greater than. What's the problem? Is it that? Oh, it's right here. So the query arrays are going to be an X value, a Y beginning value, and a Y ending value. No, I need more than that though. I also need the delta and I need the ID. Yeah. X, Y, L, Y, right, delta, ID. What's that, 5? Do I ever care? Do you do Codeforces contests as well, or just Leetcode contests? I mean, I don't really do either right now. But no, historically I've done 0 Codeforces contests. I just do the questions. Because I love to see my heat map light up. L query, R query. Do I ever care about... yeah, I do want to do the contests. And like same with Leetcode too. I feel like I'm 2023, 2024, it started to be like, okay, you got to be really good to not be screwed over by ChatGPT, but GPT-5 honestly seems like a downgrade to 4.0. And I think I am kind of at that point where I think I would still gain rating, even swimming upstream. L query, R query. Do you ever care about the left queries? Yes. Because you could have a world where you have a left query and a right query that's in a subtree, and then you have another subtree to the left of it that you have to account for, even for those left queries that don't matter within the subtree. So I have these. I also want to say right here, the left update vector, I want to just insert immediately all the initial values. So I'll say for I from 0 to n, x is, am I swapping them in? Swap value positions x and y in permutation b. So I want to start and I want to say the first thing you do pretty much is say add 1 to every x in b, add every index where it currently is. You're just like filling out b. So x is b at I, L update dot push back and place back, it's gonna be I, B1, not B, I, X1. So everything from, well, that doesn't matter. So for CDQ now, I think we can finally get to it. This is all done. I'm gonna say if you're at a single index, then you're not actually merging anything anymore. There's no left and right children. So all you're gonna do is this is actually really, this is like weirdly written. For L update and R update and L query and R query, I can't just have one of those. I need to have multiple. Right? Yeah, because you can't go top down, you have to go bottom up. So I need to construct those, which gets me back to the original problem of like, what is CDQ? CDQ is divide and conquer over the queries. And the idea behind CDQ is if you have a big tree, I saved one of these. If you have a big tree, I think hopefully I'll be able to like, I feel like you'll probably be able to understand this in like not that much time, but it's like, I don't know if I'll be able to explain it in like not that much time. What does it stand for? I think it stands for, it's like Mohs algorithm. It stands for some guy. Invented by a China competitive programmer called CDQ. CDQ D and C is almost the same to normal D and C. So I think the idea behind CDQ is you're saying, okay, I have all these queries down here. I'm gonna take like 2 minutes to explain it. So you have all these queries, right? And you're saying like, I don't know. I guess like in its most abstract form, like you have a bunch of queries, you're making a bunch of updates too. So these queries could be like actually like query some L to R, or they could be like update some index or something. And the idea is instead of doing like just a forward chronological thing, you do a divide and conquer over the time domain. And the one thing that makes it like special and interesting is that you're saying whatever queries were here that are like creating updates, when you divide and conquer, like you're going to get to some point where you're at this node and you need to merge this node and this node. When you parse this node, you do it normally. And then when you parse this node, you do it with the updates from this node. So it's like a divide and I feel like the best way to describe it is it's a divide and conquer where for any given node, for any given like interaction in this tree that you're kind of traversing, you're saying, okay, left and right both go to the parent, and also left influences right. And you're like, you form this little kind of causal triangle. So here, the way the problem is like arranged, it's like, it's interesting because this problem is almost exactly a 2D segment tree. In what order? I mean, you are doing everything left to right. Like you're still going this way. You're like DFSing down this way and then like that. Like you're doing a normal DFS left to right. I guess left influences right, then right influences the parent, and left influences the parent. Yeah, exactly. Oh, in terms of these, yeah, like that. It would be left influences right before right influences parent, I guess. But yeah, so this problem is saying you have two arrays A and B. You're trying, one query is saying, look at a range in A, look at a range in B. How many elements do they have in common? And the second query is saying change B, swap array values in B. So this is almost exactly a 2D segment tree question, right? Like it's a 2D segment tree question with point updates. But you can't do that because it's 2E5. So that's kind of the like tricky part is it's like, how do you reduce one order of n? And that's kind of what CDQ is doing here. Is you're saying like, well, for one kind of like layer of the segment tree, you also have like the X, Y, and Z, like you have like a dimension out here where like this is your binary index tree that you're like moving around throughout your DFS. And then this is the other layer is like, if you do this intelligently, you can kind of get rid of a factor of n. Because left must influence right before right influences parent, yeah. Okay, where was I? Oh, I was trying to, it's like kind of just the minutia of implementation, but I'm like, I need to have a left update and right update. I want to have these like in here. I think I'm literally just going to be like, this returns pair. Oh, it's going to be so long. Like it's going to return a pair of this and this. Or what I could say is like, that. And then I just submit, okay, these are the updates, these are the queries, like fill it up. I think I might do that. So make these, and then CDQ on L to M. I definitely want this in the back. I don't want this in the front, that's weird. So CDQ from L to M. Oh, I have that right there. With left update, left query, and then do the same thing with right update and right query. Do you like ad hoc problems or do you prefer highly technical ones? More and more, I kind of prefer ad hoc problems. Like, but I feel like I'm kind of out of practice. Like, I had to copy paste a segment tree template from some ancient code of mine. And like, it's a pretty good segment tree template, honestly. And I'm not even doing a binary index tree here. That would be like the sensical thing to do. I think, like, in effect, I probably really like highly technical problems. Just because, like, I mean, what am I doing right now? It's like some really weird arcane algorithm. But I like ad hoc ones too. I think I just naturally, like, when I'm walking my dog and I'm kind of just like asking ChatGPT about algorithms and stuff, like, that naturally is conducive to stuff like this, where it's like some obscure complicated thing, or like the Blossom algorithm, like maximum matching in like a non-bipartite graph, stuff like that. That's like really not ad hoc, but I like both. I think I just do that more because it's easier to learn it. Okay, CDQ both of these, and now I know that left update and right update are best kind of problem is when the algorithm appears out of nowhere. Yeah. There's some that are so satisfying for me. Like, ad hoc problems, usually I'm like, damn, I better be smart enough. Like, I'm in some graduate course and everybody else here is a genius. Like, I better make the cut. But it is really satisfying when there's some like div2e or something and you're like, I think it's just x over 2, and then it is, and it's some complicated proof that you just got on the spot. Or like, I think it's Dijkstra's, and then it is. Left update, left query. Are you in grad school now? No. Yeah, no, I interacted with this dude who's like a total Jeopardy head, and it's always funny to me because I'm like, this is so much brain power dedicated to like not anything. Why do you care about like random obscure Simpsons characters? I feel like I'm starting to be like, I might have fallen into the same trap with this. Because I've lost interest in going to grad school. I'm setting up to actually go to grad school for not tech work, but like I haven't lost interest. I just, the industry's so bad. Like, I think it's a better idea for me to be really good at something else that's not coding, and then it's an added bonus, like, oh hey, this guy's pretty good with computers, or like machine learning or something. Kind of like if you're in finance, I think like there's a few people that are pure finance, and there's a lot of people who are like, and another thing, like, and they're an appraiser for something else or something, you know. Okay, we got this. Well, first things first. Oh, I also need this to be auto and updates. I don't want to like create a whole new array every time. So I think what I'll do here is just say like, well, what's going on here? I have updates. I know that I was just given an empty array. That's the way that I have this set up. What are you planning on studying then? I'm straight up, like, I'm strongly considering going to medical school. Like, I'm literally taking like pre-med classes right now. Because I'm like, the niche of, first of all, I already find it very interesting. Like, I do this on stream, but off stream, I'm basically doing the exact same thing with like pulmonary embolisms and stuff like that. And I also think kind of the niche of like being willing to work hard and also wanting to make money, but then also wanting to have a social impact, but then also, I don't know, wanting to like having a tolerance for intense moments. I think like it just kind of fits pretty well. Yeah, I'm about to start like working on an ambulance in like a couple months, which I'm kind of looking forward to. But I don't really talk about that much. I don't know. That I worked as a software engineer? Nope. Well, I did. I did work as a software engineer. I did like freelance software engineering for a bit, but that honestly, that was a while ago. Okay. I want to say, like, I want to just join these by size. It doesn't really matter because it's capped to like O of n anyway. But I kind of want to say something that's like updates dot, I think it's literally update, right? This just like appends, right? Or what is it? I think I'm thinking of Python. Swap, clear, reserve, insert. What do I want to do? This is so basic. Oh, insert. It is insert. Oh, and then dot begin dot end. Okay. R dot begin, R dot end, and then I just want to say if L dot size is less than, if L updates dot size is less than R updates dot size. L updates dot swap R updates. This doesn't really matter, but might as well. Okay, and then it's the exact same thing, but for query. Fuck. L update. R update. Okay. L query. R query. Okay, and then I've successfully passed up all the updates and queries. But before I go up, I need to roll back the segment tree. So what am I going to do? I'm going to say go through all of L updates. What's the ELO of this problem? I don't know. I like to do it and then find out. And look at my little heat map here and see what ELO of problem did I just do. I would guess that this is at least 2300. This seems very complicated, and it was less people did it than G, so I don't know. But then again, I did this problem yesterday, and I felt like this was a complicated ass problem. And as a div 1 and 2D, it was just like a confusing 2DDP thing that someone like posted on Reddit. I know, I'm so confused. Like, this was so complicated, but then there's other problems. I don't know. Yeah, like this. What was the thing here? This was just a 2D sparse table. No. Yeah, or yeah. This was, you build the sparse table out backwards as you go. What was the 2700 one? Was this the 2D sparse table? N by M. Maximum square consisting of, oh yeah, this was just like a 2D sparse table with a binary search, and it was literally 2700. That's crazy. I guess I don't really need to sort it, huh? I could just use two, I don't care. I could use 2 pointers because I know all of these will begin with 1 element and then be sorted from that point on. So I could use 2 pointers down here and say, don't insert it, like do a 2 pointers thing. But this is an optimization to get to insert it at the end. No, you could definitely do this in O of n as opposed to O of n log n, but I don't care. Okay, sort L update dot begin, L update dot end. That just means I need to have, okay, this is pretty important, this piece of code. But this just means I need to have the X index here be first. That's the important part, which it is, so I'm good. The other problem is the easier it'll be. Yeah, I'm gonna run to the bathroom. Okay. It's getting there. I feel like I'm more than halfway done with the implementation. Okay, sort. Do the CDQ. That means L update, R update, L query, and R query are done. Okay, and then I change pass updates queries up. Roll back the seg tree. Here I'm what was my plan here? Process left. Do I need to do anything between CDQing left and right? No, I don't think so. I sort them, and then I update the right queries using the left updates. I'm not even going to bother sorting left query and right update. I don't need to. Recurse. How would I describe this? Update right queries using left updates. So for auto X, Y, YL. Is this how I want to write this? YR delta query ID. Index val delta. Yeah, that's fine. Query delta query ID. In our queries. While something for index val delta in L updates I gotta have the segment tree. Seems fine. Something, something, segment tree, CDQ. Segment tree of size n. Yeah. We got that. We got the query. Okay. We got 0m updates query segment tree CDQ. What's the problem here? Can I not construct it here, I'm guessing? So for every query, we have all the update indices. As long as it's less than lupdates.size and update at update IDX dot first is going to be the X value is less than. If it's strictly less than, that means it's right exclusive. Do I want to do that? No. Yeah, I'll do that, I guess. Update is less than X. So increment the update index, and then I'm going to say something that's like segment tree dot update. Well, let's see. I kind of want to just say update at update IDX. So then I'm saying update the index. No, update the value to be this delta. That has been changed. And then keep going. And then res at query ID plus equals segment tree dot query YL to YR. So look at everything in this range. That means YR has to be exclusive. Okay. Okay, if you're at exactly 1 point, then you're going to actually add this into the updates or queries. You don't need to update anything else. Well, at the very end, you could update all the original indices, actually. You could just do that at the end. Is that the smart thing to do? Yeah, I think that's the smart thing to do. Or at the beginning, it doesn't matter. So if R is L plus 1, event at L at 0, event at L at, no, at 1 and 2. X is that, Y is that. And then how do you actually add this into L update? You're adding 2 updates in. You're doing stuff, and then you're going to say swap b at x, b at y. So at index x, you're saying b at x is going down. At index y, b at y is going down. At index x, b at y is going up. At index y, b at x is going up. And then you swap them. Or what I could do is this, that's more readable. So make them go down, swap them, make them go up. Now you have 4 more updates. Or they're queries, in which case int, what are they? L1, R1, L2, R2. You need the query ID, which is just going to be the current index. X, Y, L, Y, R, delta query ID. So you're adding in 2. X equals YL and YR. Those are the easy ones. Query ID is also the easy one. That's just L. So YL is equal to events at L at three and 4. Whatever, I'll just take them all down. L1, R1, L2, R2. 1, 2, 3, 4, 1, 2, 3, 4. Okay, and then I'm placing 2 things onto queries. It's going to be, the X value is going to be L2. YL is going to be L1, R1, but it's really just +1 because it's exclusive. That's not the case for this. Or what I could do is just say this. Right, it's exclusive. Yeah. So pushback L2 means everything below the lower bound, from the lower to upper bound in A. Delta is -1 because you're taking all this out. Query ID is L. Okay, and then this is R2, L1, R1, 1, L. Okay, so the queries and updates have been added. They are correctly iterated. I'm saying for every query on the right side, look at every, do a 2 pointers with every update on the left side. Look at its X value. Get all the X values below query ID, or what am I talking about? Below the threshold, the X threshold for the query. Now you query it, and then you need to roll it back, which is pretty simple. Okay, pass them up, that part's done. The only other thing I need to do is set all the initial values. So say at the beginning, pretend there's no updates and just make everything be what it needs to be. So literally everything is getting updated with this. I think I just fill the segment tree. I think I don't need to do anything else. So segment tree N, and then this is gonna take the segment tree. Uh-oh, it hated that. CDQ M R update R query segment tree CDQ. Tuple int has no member first. Fuck. Okay. I guess that's fine. We got that. Okay, now I just need to actually fill out the segment tree. Right? No, is that right? I don't think I can do that. No, I absolutely can't do that. I have to implement all of these updates after the fact. What's the best way to do that? Well, actually, there's kind of an elegant way. I can say down here, I know exactly what the state is going to be. Call of an object of a class type without appropriate operator, conversion functions pointer to function type. What the hell does that mean? I thought you could do that. Am I crazy? Well, this is not right. I see why that can't be. All right, well, I'll deal with that later. So I build the segment tree, it's completely empty. It fills up and then empties out throughout the entirety of this DFS. The segment tree is now empty. However, updates and queries are full. So I do one more. I do one more update with everything. So I want to have the initial state of the array. I think I'll have it up here. We got updates. And then we have the initial state, which is going to be actually even above this. I'm saying set A, set B. Do I ever call, I don't even think I call A at I ever. So there's definitely one translation I need to do. That's kind of annoying. Right, I call A there. I call it there. Everywhere else I don't call it. So I think right now, what YL and YR represents is just purely indices in B, which is not right. Damn, that's annoying. That's a really annoying extra layer, huh? So it's not in B that I want to measure the indices, it's in A, which means for every B at I need to keep track of where that is in A, and then that's really the index I'm changing. So if I say B at I is X, what I'm really saying is B at I corresponds to some index in A at I. So I guess I'll just have like a translator or something. We'll call it C. So A at I is X, but also C at X equals I. So the place where this specific element is this index. Okay. So for here with initial, I'm saying B at I is X. That's great. I'm recording those values. I also want to record the updates to everything if there were no other updates. So the initial instantiation of B. So I'll say initial dot in place back something. And let's see, what are these? Index value delta. Is that right? Index value delta. Yeah, and these are all going to be 1. I'm saying insert the thing initially here. Index is C at X. That's the index in A that I'm changing. No. The index is I. That's like where it is in B. The value is C at X, and then it's being changed by 1. And then I sort it. And then that's not handled until like the very, very end. So then I need to go through and I need to say, for queries, that's fine. For the swaps though, I'm saying you're swapping this index with that index. But I don't want to say, I'm saying at this index, B at X is no longer true, but B at X is actually like the spot in the binary index tree that references this. So it's going to be C at B at X. Okay, and with that, I think it's pretty close to done. Well, no, one more thing. No instance of overloaded function. Insert. Matches the argument list. What's the problem? I think the problem might be that it's not. Oh, I actually don't know what the problem is. Oh, the final thing. Which means now this actually really doesn't matter. No, I have this backwards. End, begin, end. I think the older problem that close to solve it, yeah. With that, I'm sure it won't just randomly work, but this is it. I'm pretty much certain of the logic, even though it's really convoluted. It's just there's probably like typos and implementation errors, so I'll do a once over. We get the segment tree, we got N, M, fill it up with zeros. For the query, just add everything. It's a sum of a range. The update, add it, go back through. Probably make that a single line for loop too. Okay, I have the initial state, all of the updates, which is a dummy, it doesn't really matter. All the queries, I'm saying, ooh, I actually have to be really careful. There's a really dangerous bug in here. When I say initial.inplace back. No, that's fine actually, never mind. Okay, Philip A. C is saying if there's a value in B, it's at this spot in A, because A and B are both permutations. Okay, set B and say initially this, and that in A have these updates, these pending updates, which I don't handle until the very end. I don't actually think I ever did that. Yeah, okay, good. So I'll say, I think I sorted initial way up here. Yeah, initial is sorted. The queries though. So now I can say queries, sort queries. Oops. And then it's going to be really similar to this. So for every query that we've ever seen, int update IDX equals 0. No, it's not updates, it's initial. So I'm saying, and also, I've gone in exact reverse order for every single query. I've said update everything going backwards, even though all those updates were propagated forwards. And now I'm doing the very final thing. All these queries are meeting their maker. They're being updated with what the original array was, even if none of them have that as their actual current state. They still need to know that that was once the state. So for every query, look at every X. Is there any point to even sorting this? I'm literally emplacing by I from 0 to n, so there's no point, which is kind of nice. So look at every update, as long as it's less than the X value you're querying for. Update the segment tree, which I could clear it, but I know that after this recursive function, it should be completely clear. Yeah. And then the final thing you're doing is you're updating the query ID. Okay. Weird that you can't just say sort array. Yeah. I mean, it's like, it's the same with like binary searches. It's kind of cool that you can be like, the start and end at a random point, but it's pretty weird to me. Like, why would you not have that be an overload on the function? Why would you have like the default function be that you have to have a left and right bound? But I guess it's like probably from back in the day when everybody was working with one gigantic long array, like Roller Coaster Tycoon style, where you have to like fit every single little bit you can into everywhere. So you might as well just have one array for everything. Okay, one more roll through. So the recursive function is definitely the big guns. So this looked good. Segment tree looked good. Emplace everything in initial. That looks good. Look at all of the queries that are either queries or updates. So here, make it 0 indexed, but also exclusive of the right bounds, because that's the way I've set this up. And say, this event at this time is now a type 1 query that has 2 ranges in it. Or this event at this time has an X and a Y value, which is, I should really have them be I and J, but whatever. Now CDQ is called. So I say, make a new empty segment tree. I want to make sure I fill it with zeros. Yeah, I do. Make an empty segment tree, call CDQ. CDQ is going to say, okay, you're going all the way from the left to the right of the entire array. Why is it 0 to, oh, M. Yeah, and M represents like the number of queries. We have updates and queries, and it's purely a reference being passed down just so that we can modify it and return it back up. The segment tree, we need that, and then CDQ to recurse. So get a left and right update, left and right query. If you're at a leaf node of your divide and conquer, then you know that you need to include an event. That's all you're doing. You're just including the current query at this index, at this time step. So if it's a type 1 query, you're saying, okay, get L1, R1, L2, R2, and say, I'm now going to modify query at L, because that's our current index, with everything below the lower bound is getting taken away. Everything below the upper bound is getting added. Or else it's a type 2 query, so get X and Y. And then say, there's one less of this thing at time step X. Not, time step is confusing. There's 2 kind of dimensions of time here, but at the Xth place, this index now doesn't have something, and this index now doesn't have something because you've swapped X and Y. So the index in A that corresponds with B at X and B at Y no longer has anything. But then the index at A that corresponds with C at B at Y is what this should be. Oops. And C at B at X. That's a good catch. So when you make it up to X, the index in A that corresponds to Y, no, this shouldn't be. Close one, because I swapped them. Well, no, let me think about this. I think that is actually fucked up. Because if I swap B at X and B at Y. No, yeah, this is good. I'm saying the index that corresponds to B at X now, which is different than the previous B at X, at this same time step X, because X hasn't changed. Now there's something there. And now there's something there for Y with the exif value, or the index that corresponds to the exif value. Okay, you recurse down, so get the middle element. If you have R equals L plus 2, let's say 6 to 8, so M is going to be L plus R minus L over 2. So 6 plus that is 7, so you get 6 to 7, 7 to 8. Yeah, that's fine. Could take out O of log n if needed. I don't really care about that. Okay, update the right queries with the left updates. Query delta, query ID. So you 2-pointer it up with update IDX. You say as long as it's lower than the X value in the query, you include that in the segment tree. And then you query. Okay, that looks pretty good. And then you roll it back. And then you pass them up. This is the same thing, but with initial, which should be fine. And then you print everything. Hmm. One, two, three, four, 5. 1, 2, 3, 4, 5. That's still going. Is that loud? No, that's fine. So it hates this. Probably because I need to say return. So it doesn't just keep going. Yeah. -4420 -7. That doesn't sound right. 11120. I'm saying these are the two arrays. Look at everything from 1 to 2 in A, so we got 5 and 1, and 4 to 6 in B, so 1, 4, and 6. So we should have 1. But mine's not saying that. What happens if I get rid of this part? This should be empty. Damn, but it's not. Interesting. Update value to delta. Update value to delta. So in what world is this not going to -1? Or is this not all going to 0? One -1 0 0 1 0 0 -1. Interesting. So this doesn't do anything. Well, it's going through a lot, that's for sure. Update. Well, I think I'm forgetting one thing here, which is segment tree.query. But then it's also times Q delta. You might not be adding it. Res query ID equals YLYR times Q delta. Times Q delta, segment tree.update val, U delta. Good boy. We'll go outside soon. We're gonna go outside soon, okay? Good boy. So up to index 3, it's saying there's no updates. Which sounds probably right, actually. Well, no, I don't know. At index... It's him. The man whose identity I stole. So the segment tree has been... No, this makes sense, because for the initial... Let's see, sorry for the flashbang. At... No, I'm good. So if you're at index 3, that's here. And you're saying, what's all the modifications to the segment tree? You're either looking at this merge operation, in which case the answer should be nothing, because you're recursing back up. Or no, it should be these for sure. It should be these modifications to the segment tree. No, it shouldn't. You're at the only way there will be any modifications to the segment tree here. No, yeah, it'll be if there's a modification here. I see. So the problem is, in fact, that right here I'm saying all these updates, I'm updating the segment tree. And then I'm rolling it back, which is fine, except I'm actually not updating the segment tree before parsing the right subtree. So I want, ideally, this CDQ to be down here. I want to parse the left subtree and then CDQ and then parse the right subtree. Because this relies on whatever the segment tree state is. But then the problem is like that, no, is that true? No, that's not true. That's not true at all. I don't care about that. Where did I get that idea from? Okay, so these should all be zeros. This is saying if you're ending at index 3, well, no. Okay, I'll make this simpler on myself. What happened here? Okay. Yeah, I can look at that one. So index 1 to 3, that's saying you're looking at exactly this subtree. Index 1 to 3, it should say, yeah, there's no, the segment tree will not be modified at this point. When is the segment tree persistently modified? Because right now, I don't think there's any step in the process where after this point, the segment tree isn't modified. So when is the modified set? When does that actually matter? Or is the segment tree always just empty? keep it when you go down. Right? So right here, I said you roll back when you go up. Do you recurse when you go down? No. Or do you roll back when you go down? No. But here, it's kind of saying when you go down, you don't include the binary index tree operations. You insert all updates. Like, I don't see why the segment tree would ever have anything in it at the start of a merge operation. It should just be always empty, right? Because you're saying, okay, I care about the operations here, and I need to look back at here and say, if this is an update, then like do something. And then roll it back, the segment tree is empty, and then when you're here, you're saying, I need to look back at these for potentially both of these. Every CDQ merge starts with an empty segment tree. Okay. So that's not the problem. Let's see. Well, then it is the problem though, because why is this ever not empty? 5 to 7. So somewhere along the way, this is not exactly canceling out this. For auto, value, and delta in L update, I think it's that I'm not including all of them. Right? Like this could update some of them, and then update IDX isn't full, and then this is undoing updates that were never actually put in. So I need to change the rollback. I just need to say something that's like for, let's see, update IDX plus plus. So for undo IDX, why not? 0 update IDX, because this is gonna be the first thing that isn't included. That is that at undo IDX, and then undo it. Now these should be all zeros. Perfect. Still getting really weird answers, but that problem has been resolved. So why would I get like a bunch of nothing? That's very odd. Well, yeah, val negative delta. That's fine. If I get rid of this, does it make any more sense? No, it doesn't, because why would this go up? That would mean that here, for X and Y queries, blah, 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 blah. Get the X value, make sure it's less than X. All these, this doesn't matter. Update it by the update delta. And then go YL to YR. I guess I'm kind of curious what's in here. So print L. And then I'll say for what's a nice way to do this? Say that, and then I'll say test equals x, c at b at x, -1. Print it. Y, c at b at y, print it. And then x, c at b at x1, y, c, b at y1. Oops, so these are gonna be the updates that are added in ever. Oops. So at index 1, there's an update, which sounds right. It's saying swap 2 and 4. So swap this 5 with this 1. Which mine should say at index 1, this goes up. Well, it's kind of confusing. It's saying index 1 goes up at x equals 1. Index 1 goes down at x equals 2, 3. Index 0 goes down at 1 and 0 goes up at 3. So is that what it says? Index 1. Zero and 1, 0. Seems right. 1, 0, -1. That's saying at time step 1, index 0 goes down. Two and 4, 2, 3. At time step 1, index 0 goes down because this 5 is no longer matched with this. Time step being like how far along it is in B. 3, 4. And then at time step 1, it goes up, which is this. And then it's also saying at time step 3, index 1 goes down. 1, 2, 3. At index 3, this 1 goes down because the 1 isn't there anymore. At index 3, 0 goes up because the 5 is now here. Yeah, that's right. Okay. So I guess then maybe the queries are off. Well, what's this one saying? So it clearly corresponds to indices 3 and 0. So here it's saying 2, 4, 1. 0, 2. Well, actually, there's one more thing. Let me see. That might be throwing it off. No, I don't think so. I throw everything into initial before I change the array around. So that should be fine. Two, 4, and 1. So this 2, 3, 4 is swapping with this. But this 1 is not a 1, it's a 5 because previously it was swapped with a 5. I kind of want to just print like X and Y. Oops. 1 and 3, 3 and 0. Well, that's not really what I want to do. So this is swapping a 5 and a 1. At index 2, 3, and 4, that's fine. And then it's swapping a 5 and a 2 at 1 and 4, because now the 5 has been swapped to where the 1 is. Okay, well, that's working as intended. There's testing the queries. This is going to be R2. These are going to be, I think, a little harder to read. But I'll just look at the first one. So it's saying at x equals 3, you're going to query from 0 to 2 at time step 0. And you're going to take that out. So it's saying from 1 to 2 and 4 to 5. So if this is querying from 1, 2, 3, 4 to 5, I think this is probably where the problem is. I think it's that I don't want to say L1 minus minus L2 minus minus. I think it's that because I'm 0 indexed and non 1 indexed, I think I want to say R1 plus plus, R2 plus plus. Because this is saying, no, is that right? This is saying L1 to R1, 0 to 2. And right here, 1 to 4. No, that's not the right thing. 1 to 2, 4 to 5. So it's saying, no, 0 to 2 is right. And 4 to 5, this should say, well, let's see. 1 to 2 is just going to be this. So what my thing should say is include everything up to index 2. Don't include anything below index 0. Or I'm saying up to. Include everything below index 2. Exclude everything below index 0. That will get you index... index 0 and 1. Okay, probably got to go in a minute. It sucks though. This is like the final little touches. Yeah, that's definitely not right. Okay. L1, R2, L2, R2. So I'm gonna run through this one more time. Are the queries being implemented properly? So this is saying at x equals 3, query y from 0 to 2, take that out. So 1, 2, 4, 5. Query y equals 0 to 2. So that is this correct range. So that's correct. And it's saying at x equals 3. 0, 1, 2, 3. I'm saying everything. I think I want 1 below this, because I've made y be exclusive for the left and right in a way, but for x, it's not. So I think I really want to say right? This 3 is like not right. Because if I'm saying query from 4 to 5, 0, 1, 2, 3, or no, 1, 2, 3, 4, 5, I'm saying query here. Or no, do I just have it backwards? I think here this should be 1 and -1, or else like necessarily my values will always be negative. It depends on if it's a prefix sum or if it's like an aggregate sum, and it's kind of halfway in between. No, it should for sure be -1, but it should be L2 minus 1. 3 to 5, 0, 1, 2, 3, 4, 5. Yeah. 1, 1, 0, 0, -1, a little closer. 1, 1, 1, 2, 0. So for the final thing, it's saying from 4 to 4, 1 to 3, 0, 1, 2, 3, 4 to 4, and 1 to 3. And it should say, oh no, this 2, 4 to 4, 1 to 3. And it should say you swapped the 2 out, so that doesn't exist anymore. Three to 3. No. Add index 3. From 3 to 4, increase by 1. Add index -1 from 3 to 4, decrease by 1. A negative index is really weird. What is that saying? 4 to 4, 1 to 3. It's saying anytime anything begins with 1, you're always gonna... Yeah, that's fine though. That's just saying like you're always removing nothing. Shouldn't really matter. -1 to 3 exclusive. I don't know about that. This is saying from index 1 to 2 and 4 to 5. So for 4 to 5, that's these. You're saying keep going up until you get to this 3. So I think I was actually wrong just a moment ago. This should not be L2 minus 1. Because this is everything strictly less. It's weird that that completely does not affect the very first query. It makes sense that that would be 0 before this is queried. But after this is queried, that makes like 0 sense. So it's saying, okay, you have 2, 5, 3, 1, 4, 6. Updates. Oh. Is there a really dumb reason for this? It's that this needs to be initial. And I forgot to change that. Yes. Oops. 11120. Oh my god, what a waste of time. Well, that is the correct series of things here. Finally solved. We'll see. I think this will be the hardest problem I've ever done. If I can solve this. I didn't exactly do it in the vacuum, but that's okay. For all I know, I haven't done it yet. Come on, don't fuck me on this. All right, I really gotta call my girlfriend back after this. So, oh, very good sign. You'll love to see it. Yeah, I was about to say, I'm not gonna wait for this. I'm just gonna look at that. But this, oh, there it is. The suspense was building. That feels good. Thank you, Sake, and Simple Colon. Whew, that feels good. Let's see what rating that was. Please don't be like blue. I don't know. I think that was the hardest problem I've ever done. What are other problems I've done that are hard? MST modulo graph. That was kind of hard. Balancing weapons. Balancing weapons was really, that one was really weird. But I don't know, this is a div 2D. That's fine. And then this was a, if I'm not mistaken, div 1 and 2. Oh no, div 2. Div 2E. This one was crazy. A cat lives on a tree with n nodes. The cat starts on node 1. You live on node n. You're going to leave the cat a note written in the parkour language to help it reach you. Parkour language has 2 types of instructions. 1, this is meant that the cat should move to any adjacent node. If there are multiple options, it will pick one of them arbitrarily. If it has no adjacent nodes, it'll not move. 2, it'll destroy node U and all adjacent edges to it. If that cat is currently on node U, it will die, so this should be avoided. If node U is already destroyed, then nothing will happen. There cannot be 2 consecutive instances of the second instruction. Ah, okay. Interesting. Fortunately, the parkour language is ambiguous because the cat may have multiple options for each instance of the node instruction. So you should construct a sequence of instructions of length at most 3n, so that if the cat follows them, it will end up at node n. It always exists. Does it always exist? I almost feel like I can think of like, if you had this, that's node n, that's node 1. Oh no, that's fine, because you can do consecutive of operation 2 in a row, or of operation 1. So you'd say destroy this. So like 2. Let's say this is 1, 2, 3, 4. So you're here. Cat starts here. You'd say, okay, destroy node 2, move once, destroy node 3, move once, and then you're done. Leo, what are you doing in there? What are you doing, buddy? I can hear him ripping something up. Already solved. Well, I think like, not quite, because you have to navigate to the node that you're at. And the way I'm thinking about it is treat node 1 as the root. What is he doing? I don't know what he's doing. Treat node 1 as the root. You're going to destroy some child node. You're going to say don't go there. Probably with the largest subtree. Well, you also know there's like a parity thing, right? But you wouldn't know. That doesn't really matter, because like, for example, here, you could say if you did operation 1 and then operation 1 again, regardless of whether you went there or there, you know you'll never be on this node. But that doesn't matter, because if you're below that node, you're like screwed. guess if you had like this. What do you do? Here, I mean, here you could just delete node 3 instead of node 2. If you had node 8 there, what would you do? You'd say, okay, get rid of one of these, that's fine. Either you just immediately win, but you don't know that. So you have to assume the cat went here. You'd say, I guess, delete that. And then the cat could have gone either here or here. Or the cat could have gone here and back to here. So you would just have to wait a turn. So I think it's going to come down to the parity. I think it's going to be pretty... Oh God. Waste of time. I like... Not this, just an email someone sent me. So, yeah, I think it's going to come down to just being like, okay, is a leaf node at a given parity? If not, delete it. Why would it not be that? Like, why would you not be able to just say, like, delete this, like, delete this, hop once, delete this, hop once. Now you could be here or here. So like hop again to make sure you're not. Delete this, hop, hop, delete this. And then don't you kind of know that like necessarily it's bounded to 3n? I don't know if you're saying I thought about the solution or about the waste of time thing. Yeah, because, and then you know it'll be less than 3n. That's probably why they included that. And this is like a toe stub kind of problem where it's like, it's not that hard to know that like a solution could work. It's just a complete nightmare to... Oh, no. No. It's just a nightmare to implement, except if you have like a procedure. I like these kinds of problems too, where it's like, I know there's multiple solutions that work and I feel smart for implementing one that's like easy. Why would it be a nightmare to implement? I think this would be easy to implement. I think if you didn't say, I'm going to limit myself to 3n and I'm going to limit myself to like exactly n, like in my thought process, if you were like, okay, delete this and then the thing goes here and then delete this and then it could have gone here, it could have gone here. Like that's too much. There's too much going on, you know? It's easier to be like, I don't care about any of that. I'm just going to delete leaf nodes the moment I can and just prove that I can do that. Is this worth implementing? I said I was going to call my girlfriend back in 5 minutes, like 10 minutes ago, so. What is he doing? Let's see, new file. Cat shock. What would you do? Have a top sort, look at any node that's a leaf node. You can say you're traveling close to light speed. That's what I'm gonna say about that problem I just did. That in a real contest I would be on a warp speed ship and I would have been completely valid to do this over the course of 4 hours. So you get a... You get a top sort, you look at every leaf node and its distance. You delete the furthest distance leaf nodes. You don't even need that. You just like organize them by depth. You delete the deepest depth leaf node as long as that's not the parity of the current depth. That's really not that bad. I'm gonna try to code that in like 5 minutes. We got n. No, I don't want to. I'm going to keep them the way they are. .285. We got that. That. Depth is filled with zeros. I don't even need to do that. ADJ and +1. Let's see. Auto. DFS, and then I'm going to have vector pair int. I think I'm not going to debug this. It works or it doesn't. Nodes. And then this is going to be U and P. And it's going to be nodes 1, 1, DFS. This is going to fill nodes. Okay, vector int res while nodes while not nodes.empty, do something print res. Okay, the DFS is going to be, I also want like the current depth. Why do a DFS then sort by depth instead of just doing a BFS and not having to sort? This is faster to type, I guess. VSP continue. DFS nodes V U D+1 DFS. And then I don't even need depth. Depth doesn't matter. Nodes dot in place back depth with node U. And then I also kind of want to say if V is P or V is equal to N, continue. Nodes V U D+1 DFS. What's the problem here? Cannot deduce type. Okay. Sort it, res. Okay. Depth is going to be equal to 0. That's what it starts at. If nodes dot back at 0, no, dot first. Right, like that. Oh, I don't even need to do that. If nodes dot back at first and 1 is equal to depth and 1, res dot push back 1. That's just let the cat hop wherever, right? Yeah. Else res dot push back what the fuck is res? Res is that. I'll say vector pair int res. So this will be, no, I'm not even gonna say that. Can I do an F string? Is that the right thing to do? No, I don't want to fuck with that right now. 2 and can I just say string U? I think it's I to S. String of U. This is going to be nodes dot back dot second. Okay. Res dot push back 1. Res dot, or no. Nodes dot pop back. Okay, let's see how this does. Looks okay, I guess. 231, 221, 211. What about N? Oh, that's true. That's annoying. Damn it. All right. Well, I really gotta call my girlfriend back, but yeah, you're right. This would like destroy the tail up from N as well. So you would not include any nodes that are, you would have a custom path that's specifically for nodes leading from the root down to N. So you'd have a separate path 1 to N, and then you would do the same thing along that. And then you would just exempt, here I just have something that's like, if it's equal to N in the DFS, just like continue or something. Yeah. You would just be like, if it's equal to N, then yeah. That's true, the cat survives always. All right, well, that was an interesting problem. I wish I had more time to code it out, but I'll probably send you the solution. I'll look at it after I get off the phone. All right. Thanks for watching this monstrous problem. See ya.